Hi, I'm Joseph Tharkin of Bronx Science Harrison, and today I'll be teaching a video about tangent line approximation. Tangent line approximation is a useful calculus tool that helps you approximate or estimate the value of a function at a value that you wouldn't be able to do so without some complicated tool like a calculator. This formula that you can use will allow you to easily approximate the value of any point B using a nearby point A, knowing the value of f of A and the value of f prime of A, or the slope at A. And the formula is the value of f prime at A of f at A plus f prime at A times b minus A. And here's an example problem. Find the square root of 4.1. So the square root of 4.1 is not an exact number, and if you want to find the exact value of that, you need to use a calculator. But you can estimate it pretty well using tangent line approximation just by following the formula. For example, the square root of 4.1 is pretty close to the square root of 4, which is a value that you know, or you should know, which is 2. So using the value A as 4, you have f of 4 equals the square root of 4, which equals 2. Now f prime of 4 is a little more complicated, but the derivative of the square root of x, if f of x is root x, f prime is the square root of x. F prime is, 1 over 2 root x. That's the formula, using the power law. So, knowing that, you have 1 over 2 root 4, which is 1 over 2 times 2, which is 1 over 4. So now you have f of 4 plus 1 over 4 times b minus a. b is 4.1 because that's a value you want to find, and a is 4 because that's a value you know. So you have f of 4, which is 2, plus 1/4 of 0.1, so 2 plus 0.025, and your final answer is 2.025, which is a close estimation of the square root of 4.1. Another example of tangent line approximation will help you find equations, find values like the natural log of 1.25, which is a complicated thing that you probably need a calculator to find the exact value of, but you can estimate with pretty good precision using tangent line approximation. So first, you have to pick an A and a B. You know that B is 1.25 because that's the value you want to solve for. So A is a value of the natural log that you should know by heart, which is very simple. You just assign it to be 1 because ln of 1 is known to be 0. That's in the definition of the natural log. So knowing that, you have, using the structure, you have f of A plus f prime at A times b minus A. F of A is 0. F prime of A, well, the derivative of ln of x, so if f of x equals ln of x, then the derivative, or f prime of x, would be 1 over x. So the derivative at A, which equals 1, would be 1 over 1, which is just 1, and then times b minus a. Well, b is 1.25, we already assigned it, and a is 1. So simplifying that out, we have 1 times 0.25. So your final answer is that the natural log of 1.25 is about 0.25.